Gas metal arc welding is a process that allows a welder to work almost non-stop for prolonged periods. But in order to do this, the welding machine and work area must be set up properly. In this program, you'll see how the welding machine is set up, and you'll look at the proper procedure for attaching and changing the wire feed mechanism. For professional welders, recognizing potential hazards is an important part of the job. Fortunately, because of today's personal protection equipment along with advancements in safety equipment and procedures, all of the major welding hazards can be controlled. Safety glasses must be worn at all times in the welding shop, even under your welding helmet. The front and side coverage of these glasses protect a welder from flying sparks and slag. While welding, the helmet provides eye and face protection. Through the use of a welding shield lens, the helmet blocks both the bright glare of the arc and harmful ultraviolet light rays that could burn the face and eyes. Choosing the appropriate shade lens is important. All welding shade lenses block out the ultraviolet light, but you need to select a lens with the proper darkness to control the glare of the arc. A lens that is too light can be like looking directly at a light bulb. One that is too dark can prevent you from seeing the work clearly. So, both too light and too dark a shade of lens can cause eye strain. The selection of the proper shade lens to use can be made by consulting a chart. Following down the left side, you will select the amperage range that you are welding at, and then follow that line to the right to select the recommended shade lens number. Improper welding practices can be dangerous, but careful preparation is the best form of protection. Part of the setup for every job is looking for any potential hazards and making sure the proper precautions are taken. A typical gas metal arc welding system consists of a welding power supply, wire feeder, welding gun and cables, and work lead. The setup may also include a gas cylinder with flow meter regulator. A gas metal arc welding machine supplies a constant arc potential or arc voltage. This means that once the arc voltage is set, it won't vary even when the welding amperage is changed. The mechanism that feeds wire into the welding gun has a variable speed motor that is capable of accurately maintaining wire feed speed. The wire passes through a set of drive rollers. The rollers pull the wire off the spool and push it out to the gun. The rollers are sized to fit the wire. If the drive roller size is too small, the wire can be damaged. This can cause wire feed problems. Oversized rollers may not properly grab the wire. This results in feed wire slippage, which can also disrupt the process. The groove in the rollers is usually V-shaped and may have knurled surfaces. Knurled grooved drive rollers are often required for large diameter filler wires. The number of drive rollers can vary from one piece of equipment to another. Most wire feeders have 2 rollers. Large feeders may have 4 or more so that they can handle large diameter wires. The welding cable assembly is made up of several separate parts. Most assemblies have a wire liner, welding power cable, shielding gas hose, and control wires for starting and stopping. The cable assembly is enclosed in a heat and spark resistant covering. The wire liner is a long, flexible, spring-like tube that the filler metal passes through. The liner extends the entire length of the cable assembly. When the liner becomes worn or dirty, it can be changed. The control cable is made up of 2 or more small conductors. On some units, all of the connections are contained in one connector, but most units have 1 or more separate connections. There are many different types and sizes of gas metal arc welding guns. Most guns are air-cooled. The contact tube transfers the welding current to the filler wire and guides the wire into the weld. The size of the contact tube must match the size of the wire being used. All guns have several replaceable parts that are designed to be changed as they become worn or damaged. Wear from normal usage, weld spatter, and accidental arcing can all create the need to change the contact tube. Routine changing of the tip is easy. A gas diffuser or tip adapter is usually located between the contact tube and the end of the gun barrel. The role of the gas diffuser is to disperse the gas inside the nozzle so that it can flow evenly over the weld. The diffuser is connected to the liner with a set screw. This connection secures the liner and prevents it from being withdrawn back into the cable. Keeping the liner secured in place helps ensure that the filler wire feeds smoothly through the gun. Next, an insulator is placed over the diffuser. The insulator prevents the metal nozzle from arcing if it accidentally comes in contact with the work. Some insulators are built into the nozzle. Others are installed separately. Make sure an insulator is attached so that the diffuser is completely covered. A nozzle is placed over the diffuser and insulator. Most nozzles are made of copper alloys. Copper alloys are used because they resist damage from weld spatter and welding heat. The nozzle is attached to the gun by slipping it over a friction fitting or threading it onto a fitting. Shielding gas can be supplied by either a central manifold system that serves the entire shop or from a cylinder directly attached to the welder. When setting up a shielding gas system, make sure the welding machine is turned off. Before connecting the meter and gas, use a safety chain to secure the cylinder to prevent it from being knocked over. Remove the valve protection cap from the cylinder and crack the valve to blow out any dirt. Be sure that the valve is not pointed toward you or at anyone else before it is cracked. Connect the flow meter. The flow meter measures the flow of shielding gases and provides a means to vary the flow as needed. The flow of shielding gases is controlled by opening a small valve at the base of the flow meter. As the valve is turned, the ball inside the meter floats on top of a small jet of shielding gas. As the flow rate varies, the position of the ball changes, giving a measurement of the flow rate. To ensure an accurate reading, attach the flow meter to the cylinder in a vertical position. Connect the gas hose from the meter to the gas-in connection on the welding machine. With the gas connections complete, turn on the gas cylinder. Look for signs of leakage. Tighten any fittings that are leaking. Once the fittings are completely leak-free, you can prepare for work. When you set up a gas metal arc system, always be careful how you handle gas cylinders.
Always treat a cylinder as if it was a missile, because the minute you don't is the minute that it could become one. The high pressure in a cylinder of compressed gas, whether it be an inert gas or any kind of gas, is usually upwards of 2,000 pounds per square inch. A cylinder at 2,000 pounds per square inch with an open valve can go right through a concrete black wall like it was butter, and bones and flesh and anything else that gets in its way is not going to even begin to slow it down.
When it's time to change the wire, first turn off the power. If the filler wire spool is mounted inside of the wire feed, open the covering panel. Anytime welding is stopped, there is a small ball of metal left on the end of the filler metal at the tip. You must cut this ball off before the wire can be removed from the liner. Use a pair of wire cutters and cut off the end of the wire. If the wire is being changed while there is still wire remaining on the spool, release the drive roller tensioner. Then you can re-roll the wire back onto the spool. Be sure to hold the wire firmly between your fingers as it is withdrawn. This will prevent the wire from snapping loose and becoming tangled. Stick the end of the wire through any one of the holes on the spool side. Bend the wire so it will not unwind during storage. The method that the spool is held on the spindle varies. One method uses a snap ring that is opened by depressing the retainer. Another method is to use a locking lever. This lever is released by lifting it from the down position until it is pointing straight out. Once the retainer and any accompanying parts are removed, the spool can be slid off of the spindle. Check to see that the replacement wire is the correct diameter for the drive rollers and contact tube. The spindle has a small pen on the back side that must fit into the side of the spool. This pen prevents the spool from turning freely on the spindle, so it can be properly tensioned. Install the spool on the spindle. Secure the spool with its retaining device. Hold the wire and cut it loose. Discard the bent end that was used to restrain the wire end during shipping. The wire has a natural cast or curl, so the end must be straightened to make threading easier. With the drive roller pressure released and the roller assembly lifted out of the way, feed the end of the wire into the guide tube. The wire can usually be fed several inches into the gun liner easily by hand. Be sure that the wire is held tightly onto the spool so that it doesn't become loose and tangled. Once the wire has been slid into the liner, the drive rollers can be placed back into position and tensioned. Start with only slight pressure on the drive rollers and spool tensioner. Once you've finished rethreading, you can adjust these settings. Straighten out the gun cable so the wire can feed more easily, and hold the gun so that the cable is not bent at an angle at the gun handle. While watching the drive rollers and wire spool, start feeding the wire by depressing the gun trigger. The wire should feed smoothly. If the wire slips in the feed rollers, tighten the roller tension slightly until the slipping stops. As the wire nears the gun, you should feel the gun begin to vibrate slightly. The vibration will change as the wire gets closer to the contact tube. If the wire stops suddenly and does not come out of the contact tube, it may have become stuck. Stop feeding the wire by releasing the gun trigger. Twist the gun around to see if the wire will snap loose and pop through the end of the contact tube. If the wire does not pop loose, then it will be necessary for you to remove the contact tip so the wire can be fed the rest of the way through the cable. To remove the contact tip from the nozzle, use a pair of pliers and unscrew the contact tip. Once the contact tube is removed, pull the gun trigger again to feed the wire the rest of the way through the liner. Stop feeding when the wire extends about 6 inches to a foot out of the gun. Thread the contact tip over the wire and tighten it back into the gas diffuser with the pliers. There are 2 tensions that must be set on the wire feeder. One is for the drive rollers and the other is for the spool. If the feed roller tension is too loose, the rollers will slip on the wire, which will result in an uneven feeding or a stoppage of the wire during welding. If the feed roller tension is too tight, the wire will continue to feed if it becomes jammed in the gun or guide. To set the wire feed roller tension correctly, start and stop feeding the wire several times. This is called triggering. Begin by setting a light pressure on the feed roller and trigger the gun several times. The wire should start feeding instantly without any slippage of the wire feed rollers. If slippage occurs, tighten the feed roller pressure and re-trigger the wire. Repeat this until the wire starts instantly without the roller slipping. To make sure that the roller pressure is not excessive, hold the spool so it will not turn and trigger the gun. In this case, the wire feed rollers should slip so that the wire is not fed. It shouldn't take excessive force on the spool to prevent the wire from being fed. The spool tension should be set so that the wire spool does not coast after the wire feeder stops pulling the wire. Wire stoppage can cause the arc to instantly jump to the contact tube. This destroys the contact tube and may cause copper contamination in the weld. To prevent coasting, you'll need to set the spool tension correctly. Start by triggering the gun. The wire spool should start and stop instantly each time without coasting. If coasting occurs, slightly tighten the spindle tensioner and re-trigger the gun. Repeat this process until the spool stops and starts correctly. Understanding how a gas-metal welding system works and keeping it properly maintained is one of the keys to achieving consistent, professional welds.
Frequently, when I leave Lincoln Electric to troubleshoot in the field, one of the things that I hit most often is how far a given system, a power supply and a wire drive, be it a robotic situation, be it a hard automation or a semi-automatic manual type of setup, how far it's drifted from what we call nominal, where it should be. And when it comes time to troubleshoot your system, you have to have those components to restore it to brand new condition, so that you know that you have a source to come back. That's what you benchmark against. So if things are starting to decay, you're going to see that as a net result in the outcome, which is the weld that you're trying to make.
A constant potential power supply provides a specific voltage no matter what changes are made in welding amperage. The constant potential power supply allows the welder to set the arc voltage by turning a knob on the welding machine. The welder adjusts the welding current or amperage by speeding up or slowing down the rate of feed of the filler metal. The amperage changes because as more filler metal is fed, the arc voltage remains constant and more amperage is required to burn off the additional quantity of wire. As the feed rate of the filler metal is reduced, less amperage is required to melt the wire. As the arc voltage is increased, the arc length will also be increased. Higher voltages make the arc hotter. Excessively low arc voltages can cause more spatter. Within a range of ideal welding parameters, slight increases in amperage will result in deeper penetration of the joint. But as the amperage level is increased, weld joint penetration will begin to decrease and weld penetration will increase. That's why it's necessary to adjust both the voltage and amperage in order to produce proper welds.
Different machines use different settings. For example, newer welding machines read WFS, wire feed speed, while older machines read in amperes. If the weld procedure specification calls for WFS and your machine has an ampere setting, there's an easy way to determine the WFS. To begin, remove the gas nozzle from the gun and snip the wire flush with the contact tip. Next, hold down the trigger on the gun and run out the wire for 15 seconds. Once that's finished, cut the wire flush with the contact tip, then straighten out the wire in order to remove the curve. Now, using a standard tape measure, measure the length of the wire to the closest 1/16 of an inch. After taking the measurement, use that number and multiply it by 4. This will give you a close estimated IPM of the wire feed speed.
Now let's discuss some final setup concerns. Most importantly, the machine must be installed and set up according to the manufacturer's specifications. These specifications include such things as placing the welder far enough away from the work that it won't be covered with sparks and spatter. The machine should also be placed away from any hazards, such as moisture or water. The cables should be long enough to reach the work area, but not so long that they need to be rolled up or coiled. They must also be kept out of walkways. Now let's review the key segments of the program. 1. Choosing the appropriate shade lens is important. All welding shade lenses block out the ultraviolet light, but you need to select a lens with the proper darkness to control the glare of the arc. A lens that is too light can be like looking directly at a light bulb. One that is too dark can prevent you from seeing the work clearly. So, both too light and too dark a shade of lens can cause eye strain. 2. All guns have several replaceable parts that are designed to be changed as they become worn or damaged. Normal wear, weld spatter, or accidental arcing can result in the need to change the contact tube. Routine changing of the tip is easy. 3. Cylinder safety is important. Use a safety chain to secure the cylinder so it cannot be knocked over. Before connecting the meter and gas, remove the valve protection cap from the cylinder and crack the valve to blow out any dirt. Be sure that the valve is not pointed toward you or at anyone else before it is cracked.